In this video, we are going to analyze functions from a calculus perspective, where we pull in all of the different elements that we've looked at in this unit: domain, range, symmetry, continuity, extrema, your intercepts, and your end behavior. So the first function we're going to analyze is quadratic. And you're going to begin by making a sketch. And when you do this, you want to have your important parts as accurate as possible. For instance, like where it crosses your y-axis, your x-axis. Since this is a parabola, to help me do some of that even before I look at it on my graphing calculator, I'm going to factor this. I'm going to do x minus 4 and x minus 2 because you know what? Right away I'm going to know my zeros of my function. So I know it's going to cross at positive 2 and positive 4. I know my y-intercept is when x is 0, so if I plug in 0 there, it's going to cross up here at 8. Okay, and I also want my vertex, so I can either, again, plug this into my graphing calculator to kind of see my vertex, or the vertex occurs at negative b over 2a, which would be 6 over 2 times 1, or 3, so I know it occurs at 3. If I plug in 3 into my function, let's see, I would get 9 minus 18 would be negative 9 plus 8 would be negative 1. So my vertex is at 3, negative 1. Okay, so I didn't do an awesome job there. Kind of missed the vertex, but there's a very sloppy parabola. Hopefully your stylus or your pencil can draw a smoother one than that. All right, so my domain. Well, this is continuous on all real numbers. It goes from negative infinity. Let me try that again. Negative infinity to positive infinity. Okay, if you wrote all real numbers, that would be acceptable as well. The range, well, how low to how high? The first point that appears would be at the vertex, which would be negative 1, and that's on the graph, so it would get a bracket, and it goes up to positive infinity. Now, symmetry, meaning does it have even or odd symmetry? And just by looking at it, it is neither symmetrical about the origin, if I were to rotate it 180 degrees, nor is it symmetrical about the y-axis. So this would be neither. If it is symmetrical, you would prove it algebraically. Okay. Next, we are asked if it is continuous. So the continuity here is it's continuous. There's no discontinuity. Next, I want to know where is it increasing versus decreasing. And as I look at this, it would be decreasing from left to right until it hits the vertex, and then it's going to increase to the right. So I'm going to write this as it is increasing, or decreasing first, decreasing on the interval from negative infinity to 3. And then it switches direction and it begins to increase from 3 to positive infinity. Next, we're being asked for extrema and then our x and y intercepts. So let's look back at our graph. Extrema, this has, it's going forever up, but it does have a minimum value, and this would be an absolute minimum at the vertex. So again, I'm going to write that. Sorry for how the screens are jumping around a little bit in this video. I have an absolute minimum at of y equals negative 1 at the x value 3. Now my x-intercepts, I already did that. That's where I let y be 0, so I factored here. And I had gotten, I'll just show you x minus 4 and x minus 2. And they're equal to 0, so my x-intercepts would be 4 and 2. My y-intercept is where I let x be 0, and when I plugged in 0 for x, I got 8. And now let's look at the end behavior. So let's go back and take a look at the sketch here. So what's it doing on the ends as it goes forever left? It looks like it's going up, and it's going up on the right as well. So I'm going to write my end behavior as a limit. So the limit of the function as x approaches negative infinity is equal to positive infinity. And since it's going up on the right as well, it's also going towards positive infinity. Okay, we are going to, in this next function, you have a rational function, and you have not dealt with these a whole lot yet, but with your graphing calculator, you can really work through this. So go ahead and type this into y equals, adjust your viewing window, and make a sketch. So here's what my sketch looks like. And I'm using different technology, but I can see right away that I've got some sort of infinite discontinuity, which is causing there to be a vertical asymptote, or there is a vertical asymptote right there. There also appears to be a horizontal asymptote. It's the function approaches this value, which looks like 1 according to my sketch. All right, let's talk the domain. So as I move from left to right, okay, it goes negative infinity, and then right here I've got a break. Comes back up and shoots forever to positive infinity. So my domain goes from negative infinity to -2, union -2 to infinity. Whereas the range is going from negative infinity, and then it approaches this horizontal asymptote of 1, picks up over here and goes up towards positive infinity. So my range, negative infinity to 1, union 1 to infinity. Next, we're asked about symmetry. I would say that this has neither even nor odd symmetry. If it did, you'd prove it algebraically. As far as continuity, this is discontinuous. We have a vertical asymptote. So I will say it's infinite discontinuity at x equals -2. Now, where is this function increasing or decreasing? Well, let's take a look at this. I'm going to highlight here in blue. So as I move from left to right, this function is decreasing infinitely. Well, I shouldn't say that. It's decreasing, decreasing, decreasing. But then it jumps up to here and continues to decrease, 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 decrease. So how do I write that? It's forever decreasing, but there's a break at -2. So it's really decreasing for the entire domain. So I'm really just going to be stating my domain again. I'll just say decreasing from negative infinity to -2, union -2 to infinity. How about any extrema? Are there any relative max, relative min points, or any absolute max or absolute min points? I would say no, because it is continually decreasing. So there are none. And then we need our x-intercepts and our y-intercepts. To get our x-intercepts algebraically, you let y be 0. So I do x plus 3 over x plus 2. So what I can really do is multiply both sides by x plus 2 to get it out of the denominator, which really just means I've got the numerator, because that's still going to be 0. 0 is equal to x plus 3, so I subtract 3 from each side, so x is equal to -3. And you can verify that again on your graphing calculator. All right, the y-intercept is where we let we find f of 0, rather. We let x be 0. So if I plug in 0, I get 3/2. So it's going to be crossing the y-axis at 1.5. And you can again verify that using the trace feature on your calculator. Now let's do the end behavior. So to the left and to the right, it's approaching that horizontal asymptote. So the limit of f of x as x approaches negative infinity is 1, and the same as it approaches positive infinity. Okay, so hopefully this reviews many of the concepts. You need to practice by doing a few on your own.